Welcome back to math class. Today's lesson is lesson 7.6. It is on page 327 in your Go Math books. And we're continuing our look at fraction multiplication. Specifically, how do you multiply fractions? So we're going to take a look at the problem here. And this one is using a model, but we're going to work towards our goal of being able to multiply fractions without using models, just with numbers. Okay, so let's look at it today. Sasha has 3/5 of a scarf left to knit. If she finishes 1/2 of that today, how much of the scarf will Sasha knit today? So in order to find that, I have to multiply 1/2 times 3/5. Because again, she has 3/5 left to knit, and she's going to knit 1/2 of what she has left. So I want to find out how much she will have left after that. So my questions to look for: how much of the scarf does Sasha have left to knit? 3/5. Of the fraction that is left, how much will she finish today? 1/2 of that. Okay. Why am I doing this? Why am I taking time to do this? Because it's very important, especially in word problems, to know what information do you have and what are you doing with that information, right? I find the information that I need, 3/5 and 1/2, or that I have from the problem, and what I need to do with it is to multiply it. So I'm going to use a model to demonstrate this. I have 5 columns, and I want to shade 3/5 of this model to represent how much of the scarf she has left. So since my model split up into 5, to shade 3/5 of it, I'm going to shade 3 of the columns. This might be hard to see on the camera. I'll get in shadow a little bit. So I color 3 of the 5 columns yellow. Okay. Then, in order to find half of this, I'm going to split the whole model into 2 parts. Okay. So I split the model into 2 parts. And then to find half of 3/5, I'm going to color 1/2 of the section of yellow blue. I'm going to leave the uncolored section alone. This is what's left, and I don't want to worry about that anymore. So then I'm going to color the bottom half. Remember, just of those 3 sections, blue. And I do apologize. It is very hard to see that on here. But now, hopefully you can see that, I have 1/2 of 3/5, and I can now write that as a fraction of its own. So I'll count what's been colored blue and how many parts I now have. Notice by splitting it in half, I now have double the amount of parts I originally had. I originally had 5. Splitting it in half gave me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. And of those 10 parts, 1, 2, 3 of them, maybe it'll look better if I did it this way. There you go. 1, 2, 3 of them are shaded blue. So I will see that 3/10 of the scarf will be left. So compare the numerator and the denominator of the product with the numerators and denominators of the factors. Describe what you notice. So the numerator of the product, meaning the answer, is 3. And 3 is the same as 1 times 3. So it's the same as the product of 1 times 3 of the numerators. So the product of the numerator is equal to, math speak for the same as, the two numerators multiplied together. So interestingly, when I multiply fractions, I see that the numerator in my answer is the same as the numerators multiplied together. 1 times 3 is 3. And looking at 10, so the product of the denominator is the same as 2 times 5. So it's true for the denominator too. So I could say this is true for the denominator. Or I should say the product of the denominator. So go ahead and hold that up there. If you need a second, you can pause the video to fill all that in. But basically, when I multiply fractions, it's as simple as multiplying the numerator, the two numerators together. That gives me my numerator of the product, and the denominators together. So in a way, I find multiplying fractions is actually... Oh, sorry, I dropped you there. And we're back. I find that multiplying fractions is actually easier in some ways than adding or subtracting them, because I don't have to find common denominators. I can multiply fractions without finding a common denominator because I'm just multiplying straight across. 1 times 3 is 3. 2 times 5 is 10. And it's really as simple as that. So here's another way to look at it. 1/2 times 3/5 is 1 times 3 over 2 times 5. And I would find the same answer. Much quicker using pencil and paper, to me, or pen and paper, than doing the model way. But if you do the model, you'll understand why that happens. Okay, and again, just like we saw in the last lesson, the answer, 3/10, is going to be smaller than both the other fractions. 3/10 is smaller than 1/2, and it's smaller than 3/5. When I multiply fractions together, or a fraction by a fraction, my product is smaller than the two fractions I multiplied, because it's a fraction of a fraction. And that's what we saw in lesson 7.5 when we compared fractions. So Sasha will knit 3/10 of the scarf today. So that was page 327. Go ahead and pause if you need to fill anything in. We're going to jump ahead to 328 now, the second part of this lesson. We'll go up here, and then we're going to do the same thing, but now we're going to multiply a whole number by a fraction and see if we can still use the same process without using a model, just using that trick of multiplying the numerator by the numerator to find the numerator, the product of the numerator, and the denominator by the denominator to find the product of the denominator. Okay, if that didn't make sense, I understand. But as we work through, I think it'll make more sense. Okay, now to do this, this is very important. You can write a whole number as a fraction with a denominator of 1. Anytime you see a whole number times a fraction, you can change that whole number into a fraction simply by putting 1 under it. 4 equals 4 over 1. Why? Because 4 means I have 4 wholes. So as a fraction, it says I have 4 wholes. 1 is a whole, and I have 4 of them. So 4 over 1 is the same as 4. Get used to seeing that, because when we're working through multiplying and dividing fractions, we're going to be doing this a lot. So try to get used to that. Whenever you see a whole number, think of it as that number over 1. Okay? It'll help you out a lot to get used to that. So now all I have to do is what I did last time. Now that it's a fraction, I just multiply straight across. 4 times 5 and 1 times 12. Okay, and I'll do that right here. It's going to be 4 times 5 and 1 times 12. And what's 4 times 5? 20. And what's 1 times 12? Well, like we saw or on the other problem, any number times 1 is itself. So I have 20 over 12. Now, what I'm going to do here is put it into simplest form. Okay, which means I'm going to divide it by its greatest common factor. And if I'm not sure off the top of my head what the greatest common factor of 20 and 12 is, I'm going to do some factor trees. And I know that 20 is 4 times 5, 5 is prime, 4 is not. So I have 2 times 2 times 5. Okay, now with 12, I know that it's 4 times 3. And didn't mean to circle 4 there. So 3, so that's 2 times 2 times 3. So what do they share in common? I circle what they share in common. They share the 2 2's. So 2 times 2 is their greatest common factor, which is 4. So 4 is the number I divide by, because they can both be divided by 4, and not only can they both be divided by 4, but that's the largest number that they both can be divided by together. 20 divided by 4, well, that's the same as this. It's the same fact family, meaning it's just opposite. 20 divided by 4 will be 5, because 4 times 5 is 20. This one's a little different than this. It's 12 divided by 4, but I saw 12 divided by 4. I already saw up here, it's going to be 3. So it's going to be 5/3. But again, I have an improper fraction. So I am not simplified yet, because I can take 1 whole out of here. So I can take 3/3 out. And when I do that, I'm left with 1 whole. I took my whole out. It goes there. Then what I have left from 5/3, take away 3/3, is 2/3. So I have 1 whole and 2/3. So down here, 4 times 5/12 equals, well, it equals 20/12, but I simplified it to 5/3. Or 1 and 2/3. Okay, so here's that whole problem together, and that's how you solve it using just numbers. Okay, now we're going to look at one more problem, and this is getting us into a little bit of algebra as well, because I'm using a variable, in this case C. C is a letter that stands for a number, and in this case they give us the number 2 over 2. Now some of you may already notice, based on what we did up here when I took 3 over 3 away, that was a whole. Well, this means that this is also a whole. It's another way of writing 1 whole. It just happens to be 2 parts of 2, because my total's 2 and I have 2, meaning I have 1 whole. So what is another way to write the value of C? So C could be 1, right? What happens when you multiply a whole number by 1? Well, anytime I multiply a whole number by 1, it stays the same, right? It doesn't change. So now I'm going to replace C in the expression with what it told me to, 2 over 2. So I'm going to put 2 over 2 here. Okay? And that's the same as putting 1 over 1. I could put 1 over 1, I could put 3 over 3, I could put 4 over 4. As long as these two numbers are equal, it would all equal 1, right? But I'm going to do this. And find that equals 8 over 10. Okay? But I know that 8 over 10, if I divide by the common factor, which is 2, will give me 4/5. So I'm back where I started. Multiplying by a whole, even if it's written as any number over itself, will still give me that same number. So it's the exact same as multiplying by 1. When I multiply a whole number by 1, it stays the same. So what did I notice about my final product? It stayed the same. Just like up there. When I multiply by a whole number by 1, it stays the same. And when I multiply a fraction by a whole, or by 1, or by any fraction that equals 1, it's going to stay the same. So multiplying c times 4/5 is equal to 4/5 when c equals 2/2. It stays the same. Just like if c was 1, it would still be 4/5. Now, will I get the same result if I multiply 4/5 by any fraction with the numerator and denominator that are the same digit? Yeah, because all that's saying is that whatever number's on top is the same number on the bottom. And anytime I have the same number on top as the numerator, the same number on the bottom as the denominator, it equals 1. And anytime, so yes, because anytime you multiply a fraction by 1,